Another topic we will focus on today is the limits in calculus. As I say, limits have no limits. That's what we will find out as moving forward in this course. So limits basically are acting as a microscope to be able to look deeper and have a better insight for the certain portion of your curve. So if you look here, you have this curve and you have that exact moment, as we learned in our last lecture. What if you want to know what is the instantaneous value for that specific point in that specific time or unit? In this case, you need a magnifier to look deeper and see what's going on. The magnifier in this case for calculus is the limits. Use it to magnify deeper into your curve and try to make it look as your old mathematics and being able to solve it. So where we need the limits, when you have a slope and you want to zoom in into a certain point and try to solve, let's say I want to know how steep is the curve at point C, then I need to use my limit microscope to find out what is that. And if you want to have an area under a certain curve, as we see here, then if you want to know what is the area under the curve between A and B, then the limit is your escape for this problem. Thirdly, what is the length of the curve going from A all the way to B? Then the limit is your saver in this case, where you can solve that exact problem. We will learn in this course how to solve the limits and how to apply the limits to solve that kind of problems. So if we want to talk about the big concept that worth to mention, in real life microscope, when you zoom into some real life thing, let's say a liquid, if you put it under microscope, then things get more complicated as you zoom in and you see all those microscopic creatures and viruses and so on. So for the limits, they are a microscope. As you zoom in, as life becomes easier and things become linear and making sense. That's a rough statement, but for the sake of making it easy for you to understand what we mean by limits are a microscope in calculus. So you have here point C that we mentioned earlier. You zoomed into point C. The solid black line is your actual curve, and the dotted line is what you see as you zoom in. You can see the dotted line is getting more linear as you zoom in. Then you keep zooming in to infinity until you have a linear path for your curve. Same thing for the second picture, same for the third picture. So you're zooming in to make your life simple and make things look simpler, like you can use a simpler mathematic to solve that exact problem on that exact point. Well, infinity, as I said, you zoom into infinity. That's a very big concept used for simplification. If you say, what the heck does infinity means? Well, I would say infinity is an escape. You would try to escape, to be specific, something that you don't know. We shown by numbers that if you take the limit to infinity, you can solve the area under the curve. If you ask me how accurate is that number, I would say it is accurate enough to get our physical properties going, even though it's not a precise number, but it's an approaching number, as we will learn with limits. So you're trying to converge, you're trying to approach as much as possible to reality, but that number is not reality, if that makes sense.